So it gives me pleasure to bring on stage Ilia Yudin, DigitalGlobe representative. He will talk about MEP for Gigabytes. Good afternoon, colleagues. As always, it gives me pleasure to make a presentation at the Rakurs conference. This time around, I wanted to share with you information about a new product, a new service that DigitalGlobe has introduced recently, relatively recently. This is called Earthwatch, and this is a delivery of space imagery via internet. As you know, DigitalGlobe invests a lot of time and resources into its constellation, contributing to the largening of archives. And this data sits in the main archive, and in order to make it more accessible, modern services are required. So the company has decided that most of this data should be made available via the cloud. Originally it was by SMAP, but now it evolved into Earthwatch. A few words about our constellations. Productivity, we have 17 years worth of records, full Earth, a global coverage, some of it with 30mm resolution, more than 6,000 metro areas with 30mm resolution, and we try to image those at least twice a year to put things in perspective. Of course, there's global access. We're not limited to any particular regions, and we add our own processing so that there is homogeneity in natural good colors, as it should be among them. So Earthwatch service offers a flexible set of options. This is the premium content, global access and best value. So what do these things actually mean? What stands behind them? Premium content implies that we put into Earthwatch images with 2-day lag. So if an image was made and it meets the product criteria, Earthwatch criteria, then the subscribers will be able to see it in 2 days. Also, we're not limited in geographical terms, meaning that now billing is made based on the amount of information which a user consumes, and you can consume it by either viewing it continually, by streaming, or by ordering and downloading them to your computer and then using them offline. Premium content involves a 30cm resolution. We try to cover the entire globe with 30cm resolution, but now it's concentrated on militarized areas. If a customer sees that there is an image available for an area of interest in the main archive, but it's not available in the Earthwatch, we can include it into the Earth Watch. Also, there's a mosaic a layer offering 50 centimeter resolution for nearly all of the Earth except the Arctic region. As for the rest, where cloud cover is more or less acceptable, the quasi-homogeneous mosaic is available. We also have data updating. I guess I'll not elaborate on library. It's enormous, and if a user doesn't see images for certain dates, but they're available in the primary archives, then again it's possible to order them through Earthwatch, and they'll become available a couple of days later. An extra advantage to this service is that we have an emergency monitoring or first look monitoring feature for various sports events or natural calamities. I mean, as soon as something goes down, we try to target that area and survey that area of interest as quickly as possible. We also look at the images available for the area prior to the event to be able to put them side by side and make comparison. Like I said, we have mosaics, layers, two of them. One of them is called Metro, the other one Vivid. The Metro focuses on 1 million plus cities. This is a complete mosaic, not a block layout. For Russian cities as well, I think more than 100, and globally there is more than 6,000, some of them 50 centimeter, that is 30 centimeter resolution. Global access, another pillar of Earthwatch. Like I said, there are no limits as to our geographic scope. There can be some issues with Israel. Other than that, we can offer 30 centimeter resolution images. Another thing, the more people use the service inside an organization, the quicker they will use up the gigabyte limit. We used to have a limitation to the number of users. Now this restriction has been lifted. And this approach where customer is free to choose a mosaic or a layout, block layout, brings a lot of value because you are free to choose which particular image is better suited for your needs to inform geospatial decisions. I have a couple of applications, but I wanted to show you how this service works in real time. So I'm going to skip this slide and we'll show you how this service works using my computer. So I opened up. This is how it looks. It's essentially a Geoportal with key tools. This is the place where we are at the moment, Nana Beach. So automatically I was directed here. The latest available image is dated July 27. And here it is. Of all the available images, you can select the one that you want. I found an image for April 2017 and 2016, and we can compare any changes. I used the slider to reveal any changes, but there were now no changes, no construction. But in 2017 we can see how some construction began, resulting in the present day situation. Similarly, I can switch between and toggle between vivid mosaic layer, and in a little while we're going to have a homogeneous mosaic, even though generated not on the updated latest data, more likely data from 2015 or 16. So it takes some time to upload. Again, the image is crisper, better. Some artifacts have been removed. What else can I say? We can view the layer coverage with the most updated images that are provided with a 2-day lag to see how the Earth looks with that coverage. So a couple of buttons I gotta push. So here's what this service layer had in the past 6 months. There are unfortunately some artifacts, but they're easily dealt with. As you can see, the coverage is very massive, and archive gets updated all the time with new images coming in continually. We can switch between different modes, panchromatic, colored, and importantly, soon you will be able to extract images in the image that we provide through our resellers. I mean, ortho ready level 1, 2, or 3. So if a customer is not satisfied with this image, then they can order an area of interest, and those would be provided with all metadata and accompanying parameters. As I said, you pay by gigabytes, and it depends on the amount of content you purchase. I mean, it's various approaches to tariffication are negotiable. I guess that's all I have to say about Earthwatch. My colleague Jeremy is going to tell you a little bit about new technology, HD technology, or high definition, and new algorithm. We believe that it's relatively innovative, not to say that nobody knows about it, but still it's going to be useful. I would like to thank Mr. Viktor Lavarov for his informative presentation. Indeed, we worked a lot with him on the geological front. I'd like just to make one correction. He said that we do atmospheric correction, which we really do. It's an integrated service, but so far we're doing that only for our satellites, our own satellites. For other satellites, we attempted to work it out, but it hasn't been commercialized yet. I mean, this is the only addition or correction I wanted to make. Thank you very much, and I wish you all successful continuation of the conference. Yeah, your questions, please. Thank you. Ilia, the viewing portion, is it also a commercial service? You pay for it? Yes. You purchase a certain number of gigabytes. If you haven't drained your gigabytes by the end of the year, well, we try to figure a way. If you overspent, then your subscription runs out. As soon as you are reaching the limit, the system prompts you about there's a special window where you can track your progress. I was talking about viewing. Streaming means viewing, which is where we transmit data from our server to your screen. And each tile is worth a certain number of kilobytes. So each time you refer to that server, we count it as a tariff, basically. So as soon as you reach your limit, we don't block the access, we just restrict your zooming capabilities. I mean, your portal is still working.
Have you tried a model of data use when pixels are not really passed on to the user? Just as an example, say, PhotoMod software can take your images, do the overall vectorization, get a map, but the pixels are not passed on to orthophoto. That will be your pixels. Yes, we have such platform. It's called Geospatial Big Data, but it's a whole platform, and we do rent out images there. It's also a special model of subscription there. When the customer can subscribe to this platform, we provide a login and password, and the person gets access to the whole archive, and as well as the access to instruments that would help him process this data. So this is your software which is embedded into this platform. Yes, it is our software which you have adopted for it. Yes, the customer can install their own software there, so it's not really difficult. And there are some technical things related to that, though. But if the customer is interested to utilize the whole archive through a system of Dockers, he would be able to install their own algorithms into it and order the images they need within the system. When the image goes into a virtual computer, we apply the algorithms that the customer wants to apply. It could be our algorithms or customers' algorithms. Did I answer your question? Yes, thank you very much. More questions? Tell us, please, when you're talking about the resolution of 30 centimeters, is it pixel projection or is it a true resolution? And is it on all directions or only vertically and horizontally? In fact, this is part of the next presentation. Jeremy is our engineer, and perhaps he will be more accurate about this.
So two of our satellites are 30 centimeter native resolution in horizontal and vertical. So that means at the nadir you got 31 centimeter native resolution. When we just tilt the satellite, it can go up to 36, 37, depending on the angle.
Ну, исходное пространственное разрешение 31 сантиметр по обоим.
Actually, native resolution is 30 centimeters for both directions. So the pixel projection is the same, right? Can I also ask a question to continue on the one previously? Is it a measurable, verifiable measure? Is it mere observation, or is it really the pixel projection? Because usually the pixel projection and real or native resolution do not coincide, and native resolution is sometimes worse than the pixel projection. I believe that we have special scientific articles about this, and they're in open source access, and I can try to share them with you, which includes writings on a number of mirrors, and you can read them and see how it works, and then you'll be able to get a better answer to that. More questions?